Okay, so in this topic, we're talking about distance and midpoint formula. And so in each of these problems, you're given two endpoints of a segment and you're asked to find the distance and midpoint. And you're also asked, if possible, to simplify the radicals. And then for the distance, give the exact answer and also approximate to three decimal places. So let's remind ourselves about the distance formula. So the distance formula and the midpoint formula. So the distance formula, and so if you're given 2 points in a coordinate plane, so let's call point 1 x sub 1, y sub 1. So remember, I'm reading this as x sub 1, y sub 1. So these are subscripts, x sub 1, y sub 1. And then point 2, let's say p sub 2, so this is a subscript. Let's say p sub 2 is x2 comma y2. And so the distance between these 2 points can be written as the square root of, and then the first parentheses that we're going to have here, you're going to subtract the x coordinates from each other. And it really doesn't matter whether you say x1 minus x2 or x2 minus x1. It does not matter. Most students will just say x2 minus x1 squared. And the reason is because of that squaring part. And you're going to see what I mean in a little while. Plus, and then do the same thing with the y coordinates. You're going to say y2 subtract y sub 1 squared. And again, it did not matter. So someone else could have said the square root of, remember all this is under the square root, the radical. Someone else could have said x1 minus x2 squared plus y1 minus y2 squared. And again, it doesn't matter because remember x2 minus x1 and x1 minus x2 are opposites. And so when you square numbers that are opposites, for example, 4 squared is 16, negative 4 and negative 4 are opposites. So when you square them, notice you get the same value, 16 in both cases. So the order in which you subtract the y coordinates when using the distance formula or the x coordinates when using the distance formula does not matter. Okay? And the midpoint is the point in the middle of the segment. So the midpoint is the point in the middle of the segment. And the formula for that is, for the midpoint, the formula is, now that, remember, the middle, think half. So when finding the midpoint, you're going to add the x coordinates together. So you're going to say x1 plus x2 divided by 2. So remember, the midpoint's a point, so notice the parentheses here. That's your x coordinate. So you see that's why you say x's here. You add your x's, and then this is going to be your y coordinate, and that's where you add your y's together. y1 plus y2 divided by 2. Okay, so that's the midpoint formula. And to divide by 2, because that's the middle, you think of taking half. It's the halfway mark. Okay, so let's look at number 1. So number 1, we had these 2 points, negative 2, 4, and negative 5, negative 1. Okay, now most students, what they're going to do is they're going to label these coordinates. So they're going to call this the first point, this the second point. And so this is the first point. They're going to call this the x sub 1, the x coordinate of the first point, y sub 1, the y coordinate of the first point, and this will be x sub 2, the x coordinate of the second point, and then y sub 2, the y coordinate of the second point. Once they do that, it is just a matter of taking these values and then substituting it into the formulas. So your distance will be the square root of, and so remember, you subtract your x coordinates. So let's do x2 first. So in parentheses, you're going to say negative 5 subtract a negative 2 squared. Negative 5 subtract a negative 2 squared. X sub 2 minus x sub 1 squared. Plus, then you say y sub 2, which is negative 1, minus 4 squared. Okay? Then you're going to simplify this. So let's talk about what's inside that first parentheses. So I have -5 subtract a -2. Now remember, you're subtracting, think adding the opposite. So that becomes -5 plus the opposite of a -2, which is a +2, which we know is a -3. Okay, so that becomes in parentheses. Make sure you put that in parentheses, because if you don't put parentheses, some of you are going to say -3 squared is a -9, and it's not, because -3 times itself is a +9. So whenever you're squaring this parentheses, regardless of whether it's x's or y's, it's never going to be negative, because a negative times itself is a positive. Always keep that in mind. And then let's do the next one. So -1 subtract 4 means the same thing as adding the opposite. So that's -1 plus a -4, which is a -5. So it becomes a -5 squared. And so a negative, simplifying each one of these, a -3 times itself is is 9, +9, plus a -5 times itself is a +25. 9 plus 25 gives us 34, so this is the square root of 34. Okay, now the next thing is this. You want to simplify the radical if possible. So when simplifying square roots, you're going to think of perfect squares. So perfect squares. So remember, your perfect squares are 1, 4, 9, 16, 25, 36, and so on. Those are your perfect squares. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16, 5 squared is 25. And if you take the square root of those, square root of 1 is 1, square root of 4 is 2, square root of 9 is 3, you get whole numbers. So these are your perfect squares, and there are an infinite number of those. So besides the number 1, because 1 goes into every whole number, besides the number 1, is there any other perfect square that goes into 34 evenly? And the answer is no. So then that means that this cannot be simplified, so there's your answer. But the other thing you wanted to do, though, is to, these directions, it says also approximate to 3 decimal places. So make sure you know how to use your calculator. So you're going to take the square root of 34. So remember, on my calculator, to do the square root, that's this button right here. See, I'm going to kind of show you right here. So that's right above the x squared. To get to it, though, I have to use the second function. So I'm going to say second square root. Oops, let me turn it on first. So second square root, see the square root function right here, 34 equals, all right, now 3 decimal places. So 3 decimal places means 3 decimals, or 3 numbers behind the decimal point. So 1, 2, 3. So 0 is the 3rd decimal point. You got to look at the next number, though. Since this is 5 or bigger, the 0 becomes 1. So the answer as approximation is 5.831. So that's your approximation. All right. So that's number 1 in terms of distance. Now the midpoint, remember the midpoint's a point, so you need to use parentheses. The midpoint is where you add your x coordinates together. So you're going to say -2 plus a -5 divided by 2, comma, and then you add your y coordinates together. 4 plus a -1 divided by 2. But simplify this. Don't leave it like this. So you know that -2 plus a -5 is a -7, and the denominator is 2. Over here, the numerator, 4 plus a -1 is 3, so this becomes 3/2. Right? So there's your midpoint. And go ahead and leave it as an improper fraction. Okay, now I want to show you something, though. If I went ahead, just to kind of show you this, if I went ahead and plotted these 2 points in the coordinate plane, all right, so I'm going to go ahead and plot these in the coordinate plane. So -2, 4 is -2, 4 is right here. So that's -2, 4. And the other one was -5, -1. So -5, -1, -5, -1 is right here. Okay, and if I take a ruler, and let me quickly find where that ruler is, right here. So if I take my ruler, I'm going to draw my segment. Remember, these are segments, not lines, so don't draw any arrows. Just go from this end point to this end point. So this right here is the distance, and so this distance we found to be the square root of 34. And the midpoint is the point right in the middle, and I want to show you. So let's say the midpoint's about here. So that's your midpoint right here. That's your midpoint. And it turns out, remember we said the midpoint was in this case it was negative 7 halves, 3.3 halves. So if I go ahead and write these as terminating decimals, this is negative 3.5 and 3 halves is 1.5. And so notice negative 3.5, 1, 2, 3, 3.5, and then up 1.5. So there's the point, negative 3.5, 1.5. And so that's what that midpoint is. So the midpoint, this point right here, this point right here, the midpoint, these are the coordinates of the point in the middle of that segment. Okay, so that was number one. Let's look at number two. Okay, number two, we have this now. So number two, we have P1 is negative 1, 9, and P2 is 3, 5. And again, label your points. It helps. So this is x sub 1, y sub 1. So these are the x and y coordinate of our first point. And then the second point, we're going to call x sub 2, y sub 2. And so let's do the distance. So the distance is, and we're going to subtract the x coordinates. Let's start with x sub 2. So 3 subtract negative 1 in parentheses, squared, don't forget to square that, plus, and then 5 subtract 9 squared. Simplifying each of those values that's inside the parentheses, 3 subtract negative 1, remember, means 3 plus 1, which is 4. So I get 4 squared in parentheses. 5 subtract 9 means 5 plus a negative 9, which is a negative 4. So I get plus negative 4 squared. And then squaring each of those, 4 squared and negative 4 squared are both 16. So I get 16 plus 16. And 16 and 16 is 32. So this becomes the square root of 32. All right, now remember, you need to simplify this if you can. So think about your perfect squares. So besides the number 1, 4 goes into 32, and so does 16, right? So if you think about 4, though, I want you to think about this. So we know that 32 I can write as the square root of 4 times the square root of 8. But the problem is that 8, there's still another perfect square besides 1 that goes into 8, and that's 4. So if you recall, you should, when simplifying radicals, when simplifying square roots, you should always use the largest perfect square. It makes things so much easier for you. And so if you had used 4, you would have noticed that 4 goes into 8 as well. So this 4 times this 4 gives you 16. So it turns out that 16 is the largest perfect square. So I'm going to rewrite this as the square root of 16 times the square root of 2. 16 times 2 is 32. And the square root of 16, 16 is a perfect square. So this becomes 4 times the square root of 2. And so there's your exact answer simplified. Exact answer simplified. Okay? Now let's do the approximation. So for the approximation, use your calculator. Now, what I would do is I would do both of those because they have to be equal. So since I simplified this, just to make sure that what I have is correct, let's do both of those. So let's do the square root of 32 first. So you can do the square, and we'll go ahead and clear this. So you're going to say square root 32 equal 3 decimal places, so 6 is in that place, that third place. So since this number here is 5 or bigger, the 6 becomes 7. So I get approximately equal to 5.657. So there's your approximation. And what I would also do then is check this one as well. This better be the same as this. So let's see if that works. So 4 times the square root of 2 equals, and notice you get the same thing. So these two, so 4 square root of 2 is also equal to square root of 32. And they have the same approximation. All right, now let's do the midpoint. Midpoint, remember, that's the point in the middle. So you got when doing midpoint, you need parentheses because it's a point. So that's where you add your x coordinates together. So x1 plus 3, I'm sorry, -1 plus 3, so -1 plus 3 divided by 2. And then the y coordinates, you're going to say 9 plus 5 divided by 2. Now, simplifying the numerators, -1 plus 3 is 2, so this becomes 2 divided by 2. 9 plus 5 is 14, so this becomes 14 divided by 2. Simplify this, don't leave it like this. You all know that 2 divided by 2 is 1, and then 14 divided by 2 is 7. And don't forget the parentheses because that's a point. And so there's your midpoint. All right, so that was number 2. Okay, so that was the discussion on distance and midpoint.